Thyristor turn on. See, in this we are learning what are the different methods to turn on SCRs, and at the same time what are the different reasons for SCR turn on. Okay, using two transistor model, we have derived the equation for anode current IA is equal to alpha 2 into Ig, ICBO2, ICBO1, 1 minus alpha 1 plus alpha 2. Correct? Now, so here ICBO2 and ICBO1 is collector to base leakage currents of transistor 2 and transistor 1 if you analyze an SCR as a 2 transistor. Then Ig is a gate current, alpha 2 is common base current gain of transistor 2, alpha 1 is common base current gain of transistor 1. What is the formula for alpha? IC by IE. Okay. So if any variation in any of these variables will increase or decrease, increase the IA values. Okay. Now, the first reason, first method to turn on SCR is using gate current. Okay, we are supplying the gate current, correct, whenever we need to turn on SCR. So, when our anode is already made more positive than cathode. Okay. If a thyristor is forward biased in the sense already anode is made, we should apply voltage, positive voltage to anode, negative voltage to cathode. In the sense anode should be made, we should make anode more positive than cathode. The injection, so if a thyristor is forward biased, the injection of gate current by applying a positive gate voltage, the injection of gate current by applying a positive gate voltage between the gate and cathode terminals turn on the thyristor. So this is a very important methods to turn on the SCR. What we are doing, we are, so whenever anode is already made is more positive than cathode, in that circumstance if we apply a positive voltage to the gate, or else if you inject a current to the gate, so SCR will turn on. As the gate current is increased, the forward blocking voltage is decreased. So this is also we learned in the last class, correct? See here, so if you don't apply, okay, forget about that if you apply a gate current, if you apply small gate current, SCR will turn on. For that, anode to cathode voltage should be more than this. Okay, this is a breakover voltage for that particular Ig1. For an example, if it is a 1 milliamps, for an example, if you apply 2 milliamps, your breakover voltage may be less, means for a smaller anode to cathode voltage, for that also SCR will turn on. If you give sufficient gate current, for an example 5 milliamps, for even if the anode to cathode is around 1 volt also, SCR we can turn on. So practically in rectifier cases or in control rectifier cases or in any circuits, we are applying a sufficient Ig and we turn on SCR. We turn on SCR. So you can see here circuits. So this is a method. So we should give a supply here. Here it is shown a DC, it may be DC or AC. Okay, we should supply a gate current. In this method we should connect some gate voltage, so that gate current is injected to the gate terminals. In between these two terminals we should give the supply. So whenever anode is more positive than cathode, we say forward bias. It's not actually, anode is more positive than cathode. In that circumstance, if you apply a gate current, if you supply a gate current, SCR will turn on. Okay, this is a one method. Okay, so then next, so this is a one method, widely used methods. Okay, next, the next one is light. Yeah, is it possible to turn on an SCR using light? Yes, it's also possible. So if light is allowed to strike the junction of a thyristor, see, with this sentence is very important. If a light is allowed to strike the junction of a thyristor, in the sense, so certain arrangement should be there in a silicon such that, so there should be a option, or there should be a provision for light to strike the junction of a thyristor. If that provision is given, means if it is possible to strike the junction of a thyristor with light. So if a light is allowed to strike the junction of a thyristor, then what happens? We studied what is a light. Light consists of photons, correct? Light is, we can say that it is made up of photons. So they are all energy packets. So when that photons collides with the our gate area, the more, what happens, more number of electron hole pair increases, means a photon will give energy to the electrons which are under a covalent bond. So when an electron receives an energy from a photon, so the energy level of that electrons will increases, it will come out of that bond, so it becomes a free electrons. Once one electron is generated, means simultaneously one hole is also generated. So in this way the photon will give the photon, a particle of an light, that photons will give light energy to the electrons which are under the bonds, and because of that electrons become free electrons. So more number of electron hole pair generated, so electron hole pair increases, and the thyristor may be turned on. We have learned that when electron hole pair increases, carrier more number of carrier is increased in the junction J2. What happens automatically, that so positive feedback effect, because of that, so anode current will increase, and finally SCR will turn on. Based on this methods in a market, one separate category of SCR is available. It is called as LASCR, or else light activated silicon controlled rectifiers. So the light activated thyristors are turned on by allowing light to strike the silicon wafers. So silicon wafers, especially junction J2, that part we should expose to light. So in light activated thyristors, we will make an arrangement so that we will allow the light to strike the silicon wafers. Okay, so we learned that light consists of photons. Photons will give energy to the electrons, so electrons will become free electrons, and they are especially in the junction J2. junction J2 of a thyristor. So then mode number 1's electron is generated, hole is also generated, so hole is also generated, so continues. Okay, CR will turn on. Next, there is another method. One is applying a gate current, another one is a passing a light to the gate. Okay, then next, this is one those two are useful way, means that are those are the two methods we are using to turn on an SCR. If you are an engineer, power electronics engineer or power engineer, you are using that methods, we are using that methods to turn on a SCR. Okay, either you are using a gate current, otherwise you are using a light. So okay, if you are using a light, we should go for LASCR only. Then, is there any, we need to find out, is there any reason for SCR, is there any other reasons for SCR turn on? Sometimes what happens in your circuits, we have not supplied any gate current, and we have, it is not an LASCR, so we have not passed any light to LASCR. Even though sometimes SCR will turn on without our notice, those are all unintentional, and it will cause a damage to device circuits or entire system. So what are the reasons for such turn on, that we need to investigate. So even though we have not applied any gate current, sometimes SCR will turn on. Why? Even though we are not passed a light to the gate, wafers of a gate, but SCR will turn on. Why? Yeah, there are some such situations, we need to investigate that, because then only we can avoid such situations, so that we can protect our circuits or devices, such that unintentional turn on should be avoided. Okay, this is one reason, high voltage. Assume that in your circuits, anode is already connected to positive voltage, cathode is connected to negative. Okay, in this case I have shown DC supply. Yeah, sometimes it may be AC also. In AC, what happens, positive half cycle, usually anode is connected to high positive, I mean in the sense anode is much more than positive than cathode. Okay, in that situation, assume that we are not given, see, a gate may be disconnected, or we are not given any gate current, but sometimes the CR will turn on. Why? Why? Because if this applied voltage is very high, for an example, if it is more than 800 voltage for some series of SCRs, okay, what happens? SCR will turn on. Why? That we learned. What happens in that cases, if you connect like this, a junction J1 is forward biased, J3 is forward biased, but J2 is reverse biased. So what happens, that very high voltage whichever you are applied will cause an avalanche breakdown in J2. Okay, so if the avalanche breakdown happens at that high voltage, so very high current will passes from anode to cathode, and it will damage your SCR. So we should make sure that is we call as a breakout voltage. So see, for any SCR when you purchase from a market, we should read the data sheet. Assume that I will purchase one SCR, and the data sheet says that particular SCR breakout voltage is 800 volts. What is the meaning and what is an understanding means? I should not apply a positive voltage, means it to the anode, means I should not apply a voltage in between anode and cathode such that it should not be more than 800 voltage, or it should not reach to 800, or it should not be more than 800. Means if you apply an 800 volts to anode and cathode, avalanche breakdown happens in junction J2, and that SCR will damage. SCR will damage. See here onwards we need to understand that we should have, for a faithful or for a proper operation of SCR circuits, we use gate terminals. Whenever we need to turn on gate, we should apply the gate current. Then only SCR should turn on. Unless we apply gate current, it should not turn on. So even we have not applied any gate current, but by chance, if this applied voltage is crossing the breakover of this, then avalanche breakdown happens in J2, and unintentionally, without our notice, we have not applied any gate current. Our intention is not to turn on, but SCR will turn on. It may cause a lot of damage, because when an entire system is in off state, suddenly if SCR turns on, so much damage will occur. High power will passes, and this SCR also will get damaged, and disaster may occur. So for that reasons, so we should be very careful when we purchase an SCR. We should read it, we should read the data sheet, and we should find out what is the breakover voltage. If it is mentioning, okay, 800 volt is a breakover voltage, we should make sure that at any cost we should not apply a voltage more than 800 here in this circuit, because whenever it is in a forward means whenever anode is made more positive than cathode, if it is a DC like this, we should not apply more than 800 voltage. So if it is an AC also, in any positive of cycle, the applied voltage should not cross 800 volts. That is the meaning of that. This type of turn on may be destructive and should be avoided. So this high voltage. Next, is there any other reasons? Thermals. Yeah. See here, if the temperature of the thyristor is high, as soon as you pass a current through thyristor, what happens? The temperature will go on increases. Okay. In a circuit, sometimes the thyristor is a part of some circuit. Already that circuit or as that system areas, that system temperature is already high. If it is high, automatically thyristor temperature also will increase. Assume that the same set we have not applied any gate current. Maybe gate connection is there, but we have not given any gate current. Gate current applied is 0. What is the meaning? SCR should be in off state. SCR should be in off state. Even if it is like 200 volt is applied, that 200 volt should not pass, means current passing in this circuit should be 0. Correct or not? So SCR should be in off state only. But by chance, if the temperature of this SCR has increased because of assume that there are nearby some circuits, or there are nearby maybe there are some other part of the system, its temperature has increased, that temperature has diffused, in the sense because of the surrounding area temperature, the temperature in this thyristor is also increased. Then what happens? We need to understand. If the temperature of the thyristor is high, what happens usually? Again temperature isn't correct, no? So what happens? There is increase in the number of electron-hole pair, which increases the leakage currents. Why, if the temperature of the thyristor is high, why electron-hole pair in the junction J2 increases? That is a simple reason. You learned intrinsic carriers, correct, no? Why intrinsic carriers are generated? So they are generated because it is receiving an energy from the heat, correct, no? The surrounding that layer, or else heat is or temperature. I can say that temperature is a way of method to measure heat, correct? So the energy whichever it is this is receiving, the electron is receiving because of this high temperature, that heat is giving the energy to the electrons. So what happens now? the electrons becomes free electrons. Again one extra electron is generated. At the same time one more hole is generated. Like this, more number of electron and hole pair will generate, because it will receive energy from surrounding area whenever the temperature of the thyristor is high, in the sense everything, it is high because the surrounding area temperature is high, so that itself will cause more number of electron hole pair generation, okay, which increases the leakage current. See, the electron hole pair generation increases, in the sense what happens, ICBO2 increases and ICBO1 increases. ICBO2 and ICBO1 are leakage currents, correct? Leakage currents. This increase in the current causes alpha 1 and alpha 2 to increase. We have learned that if leakage current is increasing, see here it is in the numerator part, so IA also should increase. If IA increases, what happens? Again alpha 1 will increase and alpha 2 will increase. Again what happens? This is in the denominator part, so again IA will increase. Again IA increases means again alpha 1 increases, alpha 2 increases. Again this part increases means this denominator will decrease, so that again IA will increase. Again IA increases means alpha 1 and alpha 2 will increases. So this is a positive feedback effect. So finally what happens, this we call as a regenerative action. The alpha 1 plus alpha 2 may tend to be unity and the thyristor may be turned on. So alpha 1 plus alpha 2 may tend to be unity. This type of turn on may cause thermal runaway and is normally avoided. So that's the reasons we should make a proper cooling arrangement for an SCR, such that the temperature of the SCR should not increase. So we should remove the heat from a surrounding environment, so that we should not allow the heat to diffuse to the thyristor, so that temperature of the thyristor should not increase. So that we should avoid. That's the reason cooling arrangement is required, and cooling arrangements, it may be in terms of heat sink or fan, okay, is very much essential. Otherwise what happens, we have not given any trigger signal, or we have not given any gate current, but SCR will automatically turn on only because of this thyristor, so that unintentionally the current may pass to load, so it may cause again damage, and at the same time it may cause it may damage the SCR also, okay. This type of turn on may cause thermal runaway. This what it is because happening because of this thermal or temperature, correct? So I think we have studied thermal runaway several times. The next, see, unintentional turn on may happen when you apply very high voltage, more than a breakover voltage, or else because of the temperature. So this is one more thing we need to study. dV by dt. What do you mean by dV by dt? dV by dt, change in voltage with respect to time. Change in voltage with respect to time means variation in the voltage. Variation in the voltage. If you apply a DC voltage like this, what is the variation here? Variation is, what is the variation? If you apply a DC voltage, what is a dV by dt then? If you are applying a DC voltage, then change in voltage, DC is a constant, correct? DC is a constant, see here. So see here, if this is voltage axis and if this is time axis, if you are applying a DC, then this is a this is a DC, correct? This is a DC. So what is a if it is a 100 volts, and what you should learn straight line, correct? So change in this is 0, correct? Instead of that, if you are applying an AC here, if you are applying AC or any alternating voltage, or okay, in that cases, what is AC? Like this. So here, what is a dV by dt? So somewhere here this is change in voltage and this is change in time. It is giving, this height is giving change in voltage, this is giving change in time. Assume that this is 0 voltage and this is something around 1000 voltage. Assume that this amplitude is 1000. See, these are all concepts we need to understand very easily, very much. 1000, and assume that this happens at 1 microsecond or 1 milliseconds. Here to, okay, time being you assume that the here to here is 2 milliseconds. 2 milli. So what happens? 1000 dV is 1000 by dt is 2 milli. So 500 by milli goes to numerator 500k. So dV by dt is 500k, means how much? Yeah, that's the value, 500 into 10 to the power of 3. So for an example, if it is if this changes, or otherwise here this is one cases where change in the voltage is going to apply, correct? This is DC. Otherwise assume that suddenly somebody has applied because of some one common reason in rainy seasons and all, these flashes. Okay, so assume that some situations as suddenly voltage has increased like this. Okay, so I will tell you the time gap, time duration for this is, assume that at 1 microsecond this happens. Okay, 1 microseconds, and this is this time is voltage. Assume that it reaches to 1000 voltage. 1000 voltage. So can you tell me dV by dt? dV is how much? 1000 minus, this is 0, no? 1000 minus 0. So 1000 minus 0, 1000. dt 1 micro. 1000 by 1 micro. 1000 by 1 micro is how much? 1000 into 10 to the power of 6. This is very high. dV by dt is 1000 into 10 to the power of 6. So in such situations, sometimes SCR will turn on. Means if SCR is in off state, suddenly the variation in the voltage happens. Maybe from one level to another. This here I shown to 0 to some 1000. It may be from 1000 to 2000 also. No problem. The variation in the voltage happens, and that variation happens at a during very short duration. The variation in the voltage, variation in the applied voltage happens at very short duration. Then what? Then in such situation also SCR will turn on. So we need to investigate what is the reason for such turn on. Why SCR will turn on if the applied voltage variation, if a very high variation in the applied voltage at a short duration, if it happens, why SCR will turn on, and what is the reason for that? That we need to investigate. Okay. So this is a situation. I think situations I have analyzed, I have clarified. If the rate of rise of anode cathode voltage, means we have applied some voltage sources like this. So the rate of rise of anode cathode voltage, if this is applied in between anode cathode, that's the reason I am saying that anode cathode voltage. If the rate of rise, so rate of rise is always we measure, how we can measure the rate of rise? By taking the slope of this waveform. So what is the slope? Change in its value, and this is divided by change in time. This is, I am saying that change in amplitude, this is change in time. So that is dV, this is voltage, that's the reason I say dV, this is dt, that's the reason I will call here onwards dV by dt. dV by dt is always giving you slope of the voltage with respect to time, how fast that voltage has varied from one value to another with respect to time. In this cases, if the voltage is like this, if the voltage is like this, here change in the voltage with respect to time. The change in the voltage with respect to time for a DC, it is 0, because you have to take a slope of this change in the, if you are applying a constant 100 volts, then the change dV is 0, dt is there, but dV is 0. That's the reason slope change in the voltage is 0, dV by dt is 0 for a DC. Except DC, for all other voltages, there will be some number for dV by dt. So if that dV by dt is high, then there is some problem occurs that we need to investigate. Okay. If the rate of rise of anode to cathode voltage is high, the charging current of the capacitive junction may be sufficient enough to turn on the thyristor. We need to concentrate here. The charging current of the capacitive junction may be sufficient enough to turn on the thyristor. Okay. So see here, if you connect anode to positive potential and cathode to negative potential, so what happens? Junction forward bias, J3 forward bias, J2 reverse bias. So what happens here? So what happens here? See here. So this point, this area, I can say that here you will have a depletion region. Depletion region. Here I have a depletion region because it is junction J2. See here, in this area there is no charge carriers. Correct? This is I will call as depletion region. And here there is a charge carriers. This is any of forward bias. Here charge carriers, holes are there, electrons are there, charge carriers are there. Here charge carriers. And this area only, it is not having any charge carrier. This area is not having any charge carrier. So this junction J2 is acting like a dielectric material, correct or not? Means it is what is a capacitor? Capacitor is a, what is a capacitor? Two plates, and there is a gap. So if this plate is charged positively, some positively charged, and if this plate is negatively charged, if this plate is charged positively and if this plate is charged negatively, and there is a gap here, if it is an air or dielectric material, whatever it may be, then this we will call as a capacitor, correct or not? This is a charged capacitor. Wherever two plate is there, I can call as a capacitor, but if it is charged, then I will call capacitance. So this SCR, when you made anode more positive than cathode, so what happens here? And full charge carrier is there, here full charge carrier is there, here there is no depletion region. This is a depletion region, means where there is no charge carriers. So that region is acting like, now I can consider this as a capacitor. This is a capacitor, one plate, another plate, and in middle dielectric material. So this SCR is also acting like a capacitor. Okay. So now next questions. Okay. So you learn so many times. Okay, we'll analyze. See here. So this is a two transistor model. This is junction 1 capacitor. This because here also small usually barrier is there, but it is very small barrier potential, but J1 junction is there, junction J1, yeah, and J3 is also there. It is, but it is forward biased, so this effect is 0, this effect is 0. Okay, once it is forward biased, it is not playing a major role. It will not play a major role because it is where I can say that it is very narrow. It is very narrow, and its role is almost 0 because carrier is passing through that. Carrier is passing through that because it is already forward biased. It is not blocking the carriers. So it's it is not dominant. It is playing a minor role. We are neglecting that. These two capacitor we are not considering. But junction J2 capacitor is there. No, this capacitor, it is reverse bias. Depletion region is there. No carrier is passing. So it is purely acting like a capacitor. Purely acting like a capacitor. So this is actually only two transistor model, but in a transient model, we call it as a transient model. Means suddenly what happens when you if you apply voltage suddenly in that in the initial time, if you want to analyze the behavior of this thyristor, we need to go for transient model. In that situation, this capacitor also comes into picture. Okay, comes into picture. So this is a capacitor. It is nothing but J2. Actually, no, there is no capacitor because this reverse biased junction is acting like a capacitor. Acting like a capacitor. So what I am saying here, if the dV by dt is very high, means if you are if you doing your applied, if there is a high variation in the applied voltage in between which you have applied to anode to cathode with respect to time, in that condition the current will passes through junction J2. Means what I am saying, the current will passes through this capacitor CJ2. I am saying that. Okay, why? We need to investigate again. I think you understood now the situation. Yes. If the rate of rise of anode cathode voltage is high, the charging current of the capacitive junction may be sufficient enough to turn on the thyristor. If the rate of anode cathode voltage is high, if the rate of rise of anode cathode voltage is high, the charging current of the capacitive junction may be sufficient. The charging current of the capacitive junction, the charging current of the capacitive junction may be sufficient enough to turn on the thyristor. We will see. A high value of charging current may damage the thyristor. Device must be protected. A manufacturer. Yeah, we'll see what is this. See here, I can say that CJ2 is and VJ2 are capacitance and voltage of junction J2, and QJ2 is the charge in the junction. CJ2 and VJ2 are the capacitances and voltage of junction J2, and QJ2 is the charge in the junction. QJ2 is the charge in the junction. If the rate of rise of voltage dV by dt is large, then IJ2 would be large. This would result in increased leakage currents ICBO1 and ICBO2. First, IJ2 will increase. IJ2 is a current passing through that capacitance effect. Capacitor would be large. According to high enough values of ICBO1, ICBO2, according to your two transistor model, high enough values of ICBO1, ICBO2, what happens? Because alpha 1 and alpha 2 tending to unity and result in undesirable turn on of the thyristor. However, large current through junction capacitor may also damage the devices. Okay. See here, under transient condition, the capacitance of the PN junction, we have studied, influences the characteristic of the thyristor. If a thyristor is in blocking state, a rapidly rising voltage applied across the device would cause high current flow through the junction capacitors. The current through capacitor Cj2 can be expressed, see, because why we are not I said already Cj1 and Cj3 role is very less, so we need to concentrate on Cj2. So what is the current through Cj2? See, I think what is the current formula? Charge passing through at unit time, correct? No, charge which are crossing the unit cross section at unit time. So now what is I dq by dt? Dq means charge, change in the charges. Okay, dt. What is q formula? Q is equal to, if you are considering that junction J2 as a capacitor, charges stored in a capacitor formula, I think you are remembering, C into V. Q is equal to CV. That is the reason the charge stored in junction J2 is equal to capacitance effect of that junction J2, C. What is capacitance effect formula? C is equal to epsilon A by D. Epsilon becomes area of the plates, D becomes distance between the plates. Okay, Cj2 Vj2, this is an applied voltage to that junction divided by dt. Okay, so this is a differentiation, so we need to apply a differentiation formula, Cj2 into d by dt of Vj2 plus Vj2 into d by dt of Cj2. Okay, then so here you can see here, what is this? Cj2 into change in the voltage, applied voltage with respect to time. Yeah, as I told, it is very high, so we should consider that. This is what Vj2 into change in the capacitance value with respect to time means. So what is the C formula? Epsilon A by D means epsilon is A is area by D. If any variation in the dimension of the capacitance, that is very small, so we will neglect that. We will assume that for a simplification, we are assuming that there is no changes in the dimension of the capacitor, or there is no change in the dielectric material and dielectricity. So so this part we are making as 0, so this part we are making as 0. So once this is 0, then this is product is also 0, only this will remain, this is important. So the current passing through that capacitance Cj2 Ij2 means we are saying that because of that capacitance effect, what is the current passing through that junction Ij, that is we call as Ij2, is equal to product of Cj2 and dVj by 2. This is capacitance of that C and that junction, and this is the variation in the applied voltage. We are assuming that the variation in the capacitance of that junction is 0. Okay, that's you forget about this part now, here onwards. So you just concentrate on this. This is the dominant. It is a product of the capacitor and dVj by dt, means variation in the applied voltage with respect to time. So this is a formula for that. So using this formula we can find out what is the current passing through that junction J2 when I do a variation in the applied voltage, or whenever the variation in the applied voltage occurs. Okay, so whereas the Cj2 you will get a data sheet. When you purchase from a thyristor, they will give you the values of Cj2, so that we can analyze what is the maximum permittable variation which can occur in between anode to cathode, so that Ij2 is in the same safer area. Because if high values of Ij2 is passing, then what happens again, ICBO1 and ICBO2 will increase because minority charge carrier. So again because of that, as I told in anode current IA will increase. Once IA increases, the cathode current also increases, IK. Again both are emitter currents of the two transistors, so alpha 1 and alpha 2 will increases. Again alpha 1 alpha 2 increases means their current gain, again emitter current will increase. Again alpha 1 alpha 2 increases, again emitter current increases. So this is a regenerative effect, so this we should avoid. So again, if it continues, alpha 1 alpha 2 reaches to a high value, what happens? High values of anode current will pass, so it may turn on SCR. That is also unintentional, correct? We are not expecting such turn-ons, so it may damage your SCR also. So we should control this phenomenon. dV by dt means we should not make sure that high variation in the voltage with respect to time should not allowed. And if it happens also, if is there any chance of occurring, we should use protective circuit. So we call here nodes as number circuits to suppress or to avoid such situations. Okay, that you can study later. So first of all, I am introducing this dV by dt problem. So what is this dV by dt problem? If any high variation in the applied voltage occurs within a short duration, what happens? Charging current through that junction J2, because junction J2 is acting like a capacitor, because it is already reverse biased, the high charging current will flow. High charging current is flow, that its formula I can get by Cj2 into dVg by d2. So that charging current will increase the ICBO1, ICBO2. Because of that, alpha 1 and plus alpha 2 will increases, again IA will increase. This may cause a regenerative action or positive feedback effect, and because of that SCR may turn on. Okay, now we need to learn one problem for this, so that we can clarify that concept. See, assume, take down this problem. The capacitance of a reverse biased junction J2 in a thyristor is Cj2 is 20 picofarad. Okay, the capacitance of a reverse biased junction J2 in a thyristor is a 20 picofarad and can be assumed to be independent of the off-state voltage. In the sense, what I am saying, that can be assumed to be independence of off-state voltage means this capacitance value, there is no variation in this capacitance value. Okay, so this part is 0. I am saying that this part is means I am actually saying that this part is 0, this part is 0. The limiting value of the charging current to turn on the thyristor is 60 milliamps. Means I am saying that the maximum charging current which can flow without damaging an SCR is 60 milliamps. Means the charging current should not cross 16 milliamps, or it should not reach 16. It should be below 16 milliamps. So determine the critical values of dV by dt. Means first of all, we need to find out what is the maximum value of dV by dt that can occur. So he has given what is the maximum permittable charging current. 60 milliamps can within that it should occur. Okay, so we knew that the charging current formula is Ig2 is dQj2 by dt. Q is equal to C into V, Cj2 Vj2, d by dt of Cj2 Vj2. So Cj2 into dVj2 by dt plus Vj2 into dCj by 2. Cj2 is given already. What is the value Cj2? 20 picofarad. Yeah, we have it's given. dVj by 2 dt means that we need to find out, and Ij2 is also given, that is 16 milliamps. Okay, then Vj2, that is what applied voltage, that is not given, and d change in Cj2 by dt is also not given, but some hint he has given. The capacitance of a reverse biased junction J2 in a thyristor is this 20 picofarad and can be assumed to be independent of the off-state voltage, in the sense whatever may be the off-state voltage, that Cj2 will not vary. What is he saying, that independent of the off-state voltage, in the sense when you change the offstate voltage, this capacitance C won't change. What he is saying, that C won't change means the change in the C with respect to dt, that C is what, epsilon A by D. So there is, he is saying that there is no way changes in epsilon or A or D, A or D of that capacitance. We are assuming that there is no, so this value becomes 0. So once this is a 0 means no requirement of this, and your product is 0. So only my equation becomes like this, so Cj, now I can calculate everything, because Ij2 is 16 milliamps, Cj2 is 20 picofarad, and Cj2 is 20 picofarad, and yeah, Ij2 is 16 milliamps. So what is the question? We need to calculate this value, dVj by dt. So what is dVj by Vj2 by dt into Cj2 is equal to Ij2. So what is then Cj2 into dVj? So what is dVj by d2? So that is Ij2 by Cj2. What is Ij2? It is 16 milliamps. This is 20 milliamps. My picofarad. So it is 800 volts. Why 800 volts per microseconds? Why CL 16 by 28. So minus 3 comes here. Just verify. Minus 3. So minus 9. Minus 9. Minus 9. In 10 is there here. Minus 8. Minus 8. So minus 8 to actually 8 by that minus 8, that minus I will write as a minus 6 plus minus 2, that minus 2 I will take to numerator, plus 2, so 800 by 800 volts per microsecond. What is the meaning? Means maximum for this ACR within 1 microsecond, if the voltage is changing from if there is a change in the voltage of 800 volts, means if you are applying from 0 to 800 volts within 1 microsecond, okay, then 60 milliamps of current will pass. This is a limiting, so we should not go beyond that. Means better you should not reach to that value also. So we should keep dV by dt less than this. So 800 volt is a maximum permittable limit.